All right, hello, Algebra 2 students. This is Mr. Bear bringing you the Skill 11 notes for adding and subtracting fractions that involve rational equations that involve adding and subtracting fractions. So I'm going to start with an example and illustrate the steps. And after I do this example, I'm going to show you a few additional examples that will encounter different types of things to consider. So for this example, I'm going to solve the equation x plus 8 over x equals 6. So the first thing that I'm going to do is I am going to write each term of the equation as a fraction. Okay, so for instance, this x, I'm going to have to make that x over 1. The next thing I'm going to do is make each fraction have a common denominator. By multiplying the fractions by some number over itself if needed. Okay, so looking here, I need to identify the LCM of my denominator. So I have 1 and I have x. Oh, by the way, this 6 should have been written as 6 over 1. I already have that 1, so I'm good. So my common denominator is 1x, or just simply x. Okay? So what I have to do is multiply each part of this fraction by whatever thing is missing. So x over 1, I've got the 1, I'm missing the x. So I multiply top and bottom by x over x. The 8 over x, well, I'm missing the 1, but multiplying by 1 is not really helpful. But I'm going to show this because if that had been another number, I would have needed to multiply. And looking at this last part, I have 6 over 1. I've got the 1, I'm missing the x. So now I have the fractions rewritten. So steps 1 and 2 are done. So now I'm going to cross out all of the denominators. But before I do that, I am going to look and see what makes this LCM equal 0. So x equals 0. I need to keep that in mind because if I get an answer where x is 0, I cannot use that answer. Okay? So let's see, we cross out all the denominators, and we're going to solve the remaining equation. So x times x, so it'll be x squared plus 8 equals 6x. All right, this is quadratic, so I have to get one side equal to 0. There's no like term to do the minus 6x with, so I'm just going to write it as x squared minus 6x plus 8 equals 0. I'm going to look for two numbers that multiply to 8 and add to negative 6. So it'll be negative 4 and negative 2. So this will factor as x minus 4, x minus 2. And solving these out, I get x equals 4 and x equals 2. Both of which are not going to make the LCM 0, so both of those work out. All right, let's go ahead now and try the next one. So we talked about in the last lesson what an extraneous solution is. So if our solution matches any point of discontinuity, in other words, makes an LCM equal 0, that point, or that value rather, is going to be an extraneous solution, which is not going to actually be a solution, and so we do not want to make that as an answer. Okay, so looking at this, the first thing I'm going to notice is, oh, my fractions have a common denominator, but that 4b minus 12, I'm going to factor out the 4, and note that these will be 4 times the quantity b minus 3. So that makes my LCM 4 parentheses b minus 3. And when I'm looking at that, to keep in mind our extraneous solutions, b minus 3 equals 0 when b equals 3. So I want to keep that solution in mind. That is not actually a solution, but I want to keep that b equals 3 in mind when I'm solving this out. All right, looking here, I see that the first two fractions are already with the common denominator, but the last one I need to multiply top and bottom by b minus 3. Okay, so now I can cross out my denominators, and I get 1 plus b squared minus 6b plus 8 equals 1 times b minus 3. Simplifying the left side, I get b squared minus 6b plus 9 equals b minus 3. This is quadratic, so I have to make one side equal to 0. So I'm going to just zero out this right-hand side. I get b squared minus 7b plus 12 equals 0. Two numbers that multiply to 12 and add to negative 7 are negative 4 and negative 3. So this will factor as b minus 4, b minus 3. From this we know b is 4, and we know this one b is 3. Now remember, I went and figured out what made my LCM 0, because remember the LCM is the common denominator. If b equals 3, then that's not a valid solution. So I cannot have this one. So b equals 4 is the only actual solution that I can use. Okay. All right, let's try another example. For this one, looking at our denominators, I can't factor any of them, so I'm going to go right into the LCM. I see an x minus 7. I see a 2. And I know my LCM must be that. So while I'm thinking about it, we know that x cannot equal 7, so I'm going to keep that solution in mind if I get that as an answer. All right, let's see. I've got the x minus 7 in the first fraction, so I have to multiply top and bottom by 2. Second fraction, I've got the 2, but I'm missing the x minus 7. And the bottom, or the last fraction rather, I'm missing the 2, so I have to multiply by 2. All right, so all of my denominators are the same, so I have 2 parentheses 2x minus 9 plus x. I think that's an x, yeah. I'm going to go back and erase that just to be sure. Yep, okay. Sorry, it looked like something else for a second. All right, so my denominators, I crossed them out because they're common, so I just took my 2 times the 2x minus 9, so it's going to be 4x minus 18. Then I add x times x minus 7, so it'll be x squared minus 7x. And I got my 10 from taking the 5 times 2. Let's see, combining like terms and writing in standard form, I get x squared minus 3x minus 18 equals 10. I must have one side equal to 0. So I get x squared minus 3x minus 28 equals 0. All right, now I have to factor. So what multiplies to negative 28 and adds to negative 3? Well, that's going to be negative 7 and positive 4. So x minus 7, x plus 4. This one, x equals 7. This one, x equals negative 4. Looking at the x equals 7, we're not allowed to have that. So x equals 4. Negative 4, I mean. Okay. Last problem, this one, again, we'll notice that, oh, it looks like we have common denominators for 2 of these, but I'm going to factor out the 2. And that gives me x squared minus 7x plus 6. Let's see what multiplies to 6 and adds to negative 7. That'll be negative 6 and negative 1. Timeout. Sorry about that phone call there. Anyway, so I had factored the denominator of the first fraction as such. The second fraction is the exact same factors because of the way that it's the same polynomial. Third fraction, we have x minus 1. So our LCM for this one is going to be 2, x minus 6, x minus 1. Nothing needs exponents, so that's my LCM. So this time we have to be mindful of two possible extraneous solutions. X can equal 6 and x can equal 1. So we want to keep those in mind. Okay? Those aren't answers to this problem, by the way. That's just what we need to keep in mind. The first fraction and the second fraction have the LCM, so I don't need to do anything special there. The third fraction, I'm missing the 2 and the x minus 6. Oh, let me make that look a little better. All right, so now my denominators are all the same. So I'm going to rewrite my equation of numerators. So x squared minus 2x minus 3 equals 1 minus 1 times 2 is 2, parentheses x minus 6. X squared minus 2x minus 3 equals 1 minus 2x plus 12. Distributing that negative 2. That's how I got that. We know that this is quadratic, so we're going to have to zero out one side. Oh, I guess I should have combined like terms first, but it doesn't really matter whether I do it now or I do it later. Let's see. Oh, my negative 2x and positive 2x, those cancel out. So I get x squared minus 12, 13, 14, 15, 16. Oh, nice. This one will factor as x plus 4, x minus 4. And setting each one of these equal to 0, I get x equals negative 4, and I get x equals positive 4. Neither one of those is our LCM, so both answers work. Okay. So that is how we're going to solve rational equations that are in the form where we have to add or subtract fractions. So now you're going to have a chance to do some practice.